Greetings. For the given problem, we have to find the value of R. So to solve this, I'm going to use nodal analysis. So I will take my node here. I am taking this as my node, and so only one node is there in this problem. This is our reference node. This is our reference node. So here nodal voltage I will take it as V. Now I write the nodal equation here. So this for so the current will be flowing from the node. It's outgoing current. All currents are outgoing. So now I'll write the equation here. V minus 50 50 volt upon 6 plus V upon 7 plus 4 amps of current, outgoing current, equals 0. If we simplify this, I'll multiply the whole equation by 6. So we'll get V minus 50 plus V upon 6 by 7 plus 4 6 are 24 equals 0. Now if we expand it, V minus 50 plus 0.86 V plus 24 equals 0. So what do we get here? Now V 1.86 V minus 26 equals 0. I'll write it in the top. So next what I'll write, 1.86 V equals 26. Now what is V? V equals 26 upon 1.86. This we will get 14. So our voltage equal to 14 volt. Our nodal voltage equal to 14 volt. So here voltage is 14 volt. Now we know we have to find what is R. Now we'll apply Ohm's law to find what is the value of R. R equal to V upon I. So what is V? 14. 14 upon 4. We get 3.5 ohms. So the answer is 3.5 ohms. 3.5 ohms. So this is the second problem. Already we have solved one of first problem. So in this series of network, I'll be covering all network theorems and many problems related to network. So thanks for watching.